Hello, everyone. Good morning or good evening. Guys, I hope I'm audible to all.
Yes, look, you're audible.
Okay, super. So, shall we? So, did you get chance to go through the yesterday's session related to Ansible as well as Terraform? Guys, any doubts, any questions there? All good? Okay, just be careful. Hello. Guys, what's happening? Why no responses? All good or any issues?
Yeah, looks like. So I have one question for that. Means, you have given some notify statement in this handling, yes? So
Yeah.
why you are giving that one means we are giving the handling tasks directly, yes? So why we are giving that notify statement first and then we are going to the handling one?
The modules, whatever you define in handler, will be executed only if you notify.
Okay, means after the execution,
Mm,
the will check
Execution is
first.
successful, it
Yeah.
will automatically notify that task that you define in that handler.
Okay, okay. So that is handling in, suppose we are giving the service module, yes?
Yeah,
Yeah, okay.
right.
Yeah, yeah, yes.
Okay, fine. So shall we move on to the next topic? All of you, hope you all good with the process.
Yes.
Okay, so we talked about Terraform. We talked about the various benefits of using Terraform, and also we started with the discussion, right? Like how. Wait, let me share my screen. Like what are all the various process, the working process of Terraform. So Terraform is capable to provision the resources from any target environment. So whatever the target environment it is, you have to perform these 5 tasks. So I repeat, first you have to identify the scope, that is your target environment. Based upon the target environment, we prepare the Terraform script. These Terraform scripts are written using and saved as a .tf file. And then we have to initialize the Terraform provider that will download the Terraform provider into your project or the local machine. And then we'll perform Terraform plan that will preview your script. Once the script is valid, then you can issue Terraform apply command, which will actually implement the changes in the target environment. Correct. Now, when I say Terraform project, okay. So in order to create a Terraform project, first we have to install Terraform, and we'll be using some IDEs like Visual Studio Code to create the Terraform scripts or projects. I hope already you have Visual Studio Code installed on your machine, right? For your Python and other modules, we have used Visual Studio Code, right? Yes, no?
Yes.
So I hope you all comfortable using Visual Studio Code, or is there any challenges? Tell me, please. Okay. So today we'll see how to work with Terraform. And it is 18th of March. So in today's session, we'll see how to work with Terraform by installing it from the scratch. So as we discussed already, first we have to install Terraform. So for the installation of Terraform, we can use your local machine, or if you're not interested to use a local machine, if you already have a server in your AWS platform, you can install it in your AWS server also, no problem. Like for example, earlier you might have used for Jenkins master node or any other node, right? If you already have a server and if you want to use it for Terraform, you can use that EC2 instance to install Terraform. It's possible. Or if you want to handle these cloud resources from your local machine, you can install in local machine. So what all the process it is? So this is how we proceed with it. Like if you can see my official page here. So this is the official page from where you can able to install Terraform, like using package manager. And if you want to go with the manual installation in Windows machine, there is an option called appropriate packages. Just click on the link. So this link will allow you to do some manual installation. Manual installation means, as per the process, if you want to install Terraform in Windows machine, first you have to install this Chocolatey package manager, because through this package manager only any HashiCorp products can be installed. Not only Terraform. Tomorrow, if you're working on Vagrant or Solstack, whatever you want to install, all the HashiCorp products will be installed using this package manager in Windows machine. So if you're not interested to install this package manager in Windows machine, you can click on the manual installation tab and use this appropriate package. And here you have the option under Windows. So there is an option called MD64 download option. If you click on this download option, it will download a zip file for your machine environment. If you want, I can ping you this link. People working on Linux machine, you can try it right away, so that at least you can get some clarity. Have you all received the link? Can you all able to access that link? Are you
Yes.
trying now, or you want to do it later point of time? Like anything is fine, but I'm waiting for a response. Okay, so able to access means can you able to click on this download link and able to see the zip file which is downloaded in your local machine?
Yes.
Okay, all right. So from this link, if you are a Windows user, click on this AMD 64, this downloads button. It will download a zip file. And if you want to install, if we want to install it in Linux machine, all that we can do here is you can use any of your thing like CentOS, means you can use yum package to install these 3 lines of code. Similarly, all the Ubuntu users have to execute these 3 lines of code to install Terraform. This is the procedure. Okay. Now, Windows users, you must have downloaded it. So if you download Terraform on your Windows machine, you'll be getting a zip file, something like this. Terraform followed by the version Windows AMD 64. I have already downloaded this and it is version 1.72. It is zip file. Just right click on the zip file and you can find an option called extract all. Can you able to see this? So if you click on extract all, it will allow you to extract the zip file and you can able to find this folder, something like this. Upon extraction only, you should open the folder. Don't directly double click that zip file. Even you can get the file inside, but you're not supposed to directly access your zip file. You have to extract and then open that folder. You can find the Terraform executable. Is that clear?
So, sorry, after clicking on application file, nothing is going on.
What?
After clicking on that application file, extracting, this
I'm
this file
not
is there, right?
expecting you to click on this, right? I just
Oh,
wanted you to extract and see the file within the folder. Don't try to open this, okay? You cannot run this application. Got it? Upon extraction, can you able to see this? I just want you to extract and then see. Don't simply open this and see this file. That is not the expectation. Please extract and then access it. Otherwise, the file cannot be, accessible. Any question on this process? So I believe you're all in this folder, extracted folder, and you can see this file, right? So this is what the installation path, like the in C drive under softwares folder, I have this Terraform folder. Within that, I have this uh, application, Terraform application. It is not an executable, okay, to install. All that we do here is we have to create an environment variable now. So this is what it is. So if you are working on Terraform through a manual approach, first you have to download that AMD 64 version zip file, right click and extract that file. Once it is extracted, you can find the Terraform folder. Within that, you can find the Terraform application. All right. So till this, you're completed, right? So the next step is we have to create an environmental variable, because the file, whatever you downloaded, is just a file in your file system. Your Windows cannot recognize it. So as like how you create your environment variable in Linux machines, like a path variable, here you have to set this environment variable. Just go to your start menu, Windows menu, and then you can search for environmental variable. Just type envi. You can see there is an option called edit system environment variable. Click on this. And here you can see there is something called system properties. First listen, then you can do it one by one, okay? In the system properties, there is an option called environment variables. Click on this environment variables and it will take you to the environment variable tab. And here you have something called system variables. In the system variables, you can find there is a path variable. Click on the path variable and edit this. Once you edit, you can see there is a edit environment variable dialog. Here you have to click on new to add this path. So the folder, whatever you have, right? This folder. Click on this address bar, you'll be getting the address of that folder. Okay, just copy that address and update it here. Got it? Something like this. So click on new and paste that value here. Can you be able to make it now? Can you be able to make it now?
Yes.
Yes.
Just the folder name, okay, not the file name. File name should be there. You have to copy till the folder. Got it? Select the path, edit. So now once it is done, you can see this Terraform path is updated here and click on OK, OK, and then apply and OK. So this is the way you can able to set your environment variable. I just given the steps in detail here. To set up the environment variable for Terraform binary file, from your Windows start menu, search for environment variable. You can get environment variable settings, find a file system properties, and then select the environment variable button and update your variable there by clicking new. Once it is done, apply and save. So can you all try to do this activity now? You can take another 1 or 2 minutes time and try to complete this, because only if this is successful, you can able to access Terraform binary from your Visual Studio Code. Can you all able to make it?
Yes.
Sai, for me, that last step, uh, you applied, right? You applied and then you clicked on OK, right?
Just click on
Oh.
OK if apply is not enabled.
Okay, okay. For me, it was not enabled.
Completed, right? Anyone facing any issue there? All right. So once you're done with this, go to your start menu and search for Visual Studio Code. If you already installed Visual Studio Code, you can able to have it here. Just open this. If not, you can go to this link and install. I believe everyone have your tool available in your machine, right? Install there, right? Okay, let me open a new Visual Studio Code project. Okay. So now open your Visual Studio Code project and create a project. But the one important thing here is in your Visual Studio Code, you have to set up your extension. Okay, that is for Terraform. So once your Visual Studio Code is installed, just open the Visual Studio Code. I mean, before creating a project, you should do this. Open Visual Studio Code, and on this Visual Studio Code, install Terraform extension for Visual Studio Code. Extension name is HashiCorp Terraform. So please open this IDE, and on the left side, you can see something called extensions. Can you see this? Can you see the extensions field here? Search for HashiCorp. Terraform. Can you see this HashiCorp Terraform? This HashiCorp Terraform is the official plugin or extension for your Visual Studio Code that is supplied by HashiCorp. It is officially a certified extension. So I have already installed it. That is why I don't find an option to install. But if you get into this option, you'll be getting an button to install this. Just click on the install button. All right. I'll ping you this extension name. You can search for it. Got it? So what is the need for this extension? Why we need this means it helps the developers or users to quickly create your script. It will automatically highlight all the syntax errors and it will speed up your coding. Like by creating some context menu, you don't need to type your syntax completely. As soon as you start typing the syntax or any keyword, you can able to auto fill that syntax. It's possible. Got it. And if you make any syntax error also, it will highlight immediately. Before you execute a plan command, while you type itself, you can able to identify all the errors. All right. So any question on this? Hope we can install this, right? Can you able to install this or any question? Guys, please respond.
Yeah, it's done.
Done, sir.
Okay, super.
Yes.
Anyone yet to do or trying to complete this? Any challenges? All good? Okay. So once this is done, close this tab and you can go to your folder Explorer and you can create a new project now. Just go to File menu and click on Open Folder. If you click on Open Folder, it will take you to your file system. From this file system, you can able to search for the path where you want to create your folder. Like I think we have created a Git repository already initially in a previous module, so I can use that folder itself. Let me create a new folder in my file system. Terraform project 1. Okay. And I just want to use this folder as a project folder. All right. Let me close this welcome screen. We just created a folder and it's an empty folder. We don't have any other components there. Now, click on this terminal menu. After creating a folder, after opening your project, click on this terminal menu and go to new terminal. And here it has opened the PowerShell terminal for me. In this terminal, you can simply use your Terraform command, Terraform version command. Can you see this? When I say Terraform -- version, I'm able to use Terraform from this project folder. And the version is 1.7.2, Windows AMD 64 version. So you can able to get this version only if you properly configure your environmental variable. Can you try now, all of you? Just open Visual Studio Code, install HashiCorp extension, Terraform extension for Visual Studio Code, and then create a new project, open a new project, go to File menu and open a new folder. Once folder is opened, then you can go to your terminal and click on New Terminal and run the command terraform -version command. Possible?
Yes, sir. For me, it is showing V1.11.2.
Perfect. Perfect. What else? Hmm? Anyone trying to work on the same or facing any issues? If you're completed, please respond through chat at least. If you need time, please let me know. Okay, perfect. I can see people are responding. Yeah, no problem. If you're connected from your mobile device, that's not an issue. Try to understand what we're discussing here. If you have any question, let me know. People who are unable to implement this now, try to understand. And even for you people only, I just documented everything here. If you go through my class notes offline, you can able to understand the process and try to make it. Easy? How much time you need? So whatever we are doing here, it is a process of environment readiness. To work in Terraform project, these are all things you have to be clear. Now, once the project is ready, we are good to start our process. Means I'm going to perform all these activities now. But before you perform all these activities, you should know what are the use cases, what are the possibilities, in which situation will use Terraform. So using Terraform, you can able to create a resource, modify the resource, or delete the resource. These are three actions you can perform with the help of Terraform. Nothing else. Correct. So either you can create a new resource in the target environment. It is also called as adding resource, or you can able to change or modify the resource. Let's say I have created one EC2 instance. I want to change the name of the tag of the EC2 instance, or I want to change the volume of it, or I want to change any parameter of the EC2 instance, mean that is modification. The resource can be modified using Terraform. And if the resource is no longer required, you can simply destroy or terminate the resource. So these are three things you can able to perform with the help of your Terraform here. Correct. But how to perform this? What are all things you need to do? So in order to work on this, we need to use Terraform registry. Remember, yesterday itself, I told you, using Terraform registry only, we can able to perform all Terraform related commands. So from your installation documentation, there is a link for Terraform registry. And from this Terraform registry link, click on browse providers. Okay. So from this providers tab, which resource you want to use, just click on that resource, like AWS resources. Click on AWS. It will take you to a page where you can find your latest version of your AWS resource. From this page, click on documentation. So if you click on documentation, you can able to see it's first start with the AWS provider, right? So AWS provider, as I said, it is a kind of agent. Use this AWS provider to interact with many resources supported by AWS. So Terraform uses this AWS provider to interact with your AWS resource. So that is a very first entity, initialization. Once the resources, once the script is ready, in order to interact with your AWS through Terraform, you have to use the Terraform provider. So initialize the Terraform provider using Terraform init command. Got it? So that initialization should be done actually. And it should be a one-time activity for the particular project. You see? Now I'll show you how you can able to prepare this script. Usually, if you want to create a resource, let's say you log into AWS console, and then only you can create a resource, right? Before you access this console, you should be an authorized person. Your identity should be there. You should have access to your resources. Similarly, from your Terraform script through this CLI, if you want to interact with AWS, you need AWS access key and secret key. Correct. We need these two components to be created first, which allows you to access your AWS resource. I get your point. So before you actually create your script, we have to create AWS access key and secret key. So any idea how to create this, from where you can get this option? Have you ever tried it? Hmm?
Yes, we can create a new user.
Sorry?
Uh, we can create the new user, and there we can get the access key and secret key.
It's very simple. So before you try to access your AWS resources, it is not only through Terraform. Even tomorrow, if you use your AWS CLI commands or shell scripts, or through your Python script, if you want to access your AWS means, just from your console on top left, right, you can see your ID, right? Click on this drop down and you can find something called security credentials. Click on that security credential option and it will take you to your credential manager. Got it? It will take you to your credential manager. Just scroll down. You can see something called your MFA and other stuff. Here you can see something like access keys. I have already created one access key few days back, and you can able to create 2 access keys for free tier account. So from this tab, click on create access key. And for what purpose you are creating it? I'm going to use it as a CLI, right? Your plan to use this access key to enable AWS CLI to your AWS account, right? Like this, we can able to choose the desired action and enable the confirm this and click on next. It will ask for the key name, on which name you want to use. Like I can say like PL AWS PAT, personal access token, created. That's it. It has created one access key and secret key. Copy this access key and secret key and preserve it somewhere. Can you all able to make it? Can you all able to create one? And once it is created, before you close this panel, ensure that you preserve these keys, because once you close this panel, you cannot access the secret key again. Or click on download. It will download a CSV file based upon this content into your local machine. But before you close this panel, ensure that you copy both the parameters. Any question here? Guys? Any question? Have you ever tried this? Or is the first time you are trying to create access key?
First time.
Okay. But tomorrow, once you start with your AWS models, right? This is the very first thing you'll do. Because there will be maximum try to use it through AWS CLI commands. We all done this? Or you need any more time now? Like, or even if you can't do it now, at least you understood right how to do this. Any question? What is happening? Are we good to proceed, or you want to have some break? What's happening? Why so silent?
Yeah. Yes, sir. It's good. It's clear.
Okay. So we have created this access key and secret key. So we have to use this while initializing a provider. Correct. Along with the region name. So I'll give you a small script now to work on it. Just a minute. I'll share some more scripts for you so that it will be easy for you to understand the things. So listen, please. So here is a script to define the provider and AWS resource. So in your Terraform project, there is a folder, right? Click on this new file option and create a file name like aws.tf. So as soon as I enter the extension, you can see there is an icon comes there, right? It's because of the extension you used, like plugin you used. So now Terraform, this file has been opened in the default editor. So whenever I start typing anything, it will automatically show the context menu, and it will pre-fill all the syntax. Like I can simply use AWS. Simply, it will help me to quickly code my script and parameters. See, whenever I start typing this, it is giving the context menu to fill the content, right? So like this, once you install your extension, you can easily create your script. That is very much important. So first we are going to create a provider. So this is syntax for creating a provider in your local machine. So provider is AWS and region is AP South 1 because I'm using this Mumbai region, right? If it is Mumbai region, ID is AP-South-1. This ID we have to provide here as a region value. And then the access key. Access key is something which you just created. And the secret key, which we just created here. Correct. So this is about provider. This provider, what will do means it will search for the AWS provider and download the provider to your project, and also allows you to access the AWS resources. It will enable the access to define the resources. Once provider definition is done, then to create a EC2 instance, this example will help you to create one EC2 instance actually. So for creating this instance, this is syntax resource and type of resources AWS underscore instance and the instance name. I want to create one instance and it is named as instance 1. And to create a AWS instance, we need AMI, instance type, key name, and you can give some tags also. So these parameters, you can take it from your console. Like you can see, right, while launching the node, based upon which instance you want to create. Let's say if you want to create Amazon X means this is a instance ID. Correct. Just copy this instance ID. Ensure that you are using this instance from the region which is mentioned here. From your AWS AMI list, you can take it, or I can go to your AMI's catalog also. So from this list of AMIs also, you can able to choose the AMI ID. It's possible. Got it? So copy this AMI ID and have it in your script. And instance type, it can be T2 micro, and the key name, which key I want to use. The key name is AWS 2025 hyphen key pairs 1. From here you can choose, or if you want to choose any other key, there is a catalog list for key pairs. Correct. So from there also you can able to choose that there is a key pairs option. So this will get you the complete list of key pairs created in your machine. See? So this is the index name. So this also you can able to refer here. You see? And then the instance, like I can simply select PL test instance 1. This is a tag I want to assign. So from where I get this script means if you go to your provider documentation, here AWS provider, we have the syntax. Can you see this? I just copied from here, nothing else. Similarly, to create a EC2 instance, I use a syntax here, resource AWS instance type. So just go to your resource and search for EC2. You can able to get the complete list of resources like EC2 means Elastic Compute Cloud. From here, you can able to get the instance details, how to create an instance. Here it is. And this is a parameter to create the instance. I just copied this only, nothing else. You see, resource type is AWS instance and the name of the resource. What are the parameters you need? Just pass the parameter to define it. And in real time also, it is always recommended to go to this official page and get the syntax from here. Why? Because very frequently there'll be some changes happen in this resource, right? They'll be creating a new versions very frequently, monthly, at least there'll be 3 releases or 4 releases. So in order to keep your script up to date, it is recommended to use the latest documentation and take the script from here. Correct. So with this, we can able to prepare the script. Just have it in your script file here like this. All right. Any question? Any question in preparing this script file?
We need to define only this tag and all the things, yes, in this
Yeah.
script, the bottom, yeah.
Yeah. All other parameters like VPC and all, it takes from the default one. If you want, you can create it explicitly. I'll show you how to create that also.
Yes.
But first, let's understand the fundamentals. So first, you need to understand how to create a Terraform project, how to define a provider, and then how to give a resource definition. And once the resource definition is script is ready, just go and save the file. Go to File menu and save this. Upon saving this file, since it's a very new project, you have to execute your Terraform init. Remember, we are performing all these things one by one now. First, we have identified the scope, and then we have written the Terraform script now. After writing Terraform script, we have to perform Terraform init. So use a command Terraform init command. See, it is initializing the provider plugins. Installing HashiCorp AWS 5.91.0 is the latest version. Yeah, 5.910. It is installing now. Can you see this? And if you observe the folder structure, initially I was having only one file like AWS or TF, which I created. But now as part of this initialization, it has created a new folder called .terraform folder. Within that, you can able to see some components like your provider, Terraform-provider AWS 5.91.0. So this provider has been downloaded to my local machine. So that is what your Terraform init means. Terraform provider is a kind of agent to be installed in the local machine to provision the target resources. So once init is done, what is next step? We have to perform Terraform plan command. And even it is giving a recommendation for you. You can see Terraform has been successfully initialized. You may now begin working with Terraform. Try running Terraform plan command to see any changes are required in the infrastructure. So now if I say Terraform plan, Terraform plan command. So what I said about Terraform plan command, it will preview the script. See, as part of the Terraform plan command, it is previewing the script, whatever written here, and is identified there's something to be created. So what we have to create here, that will be identified by this actions here. So it is going to create an EC2 instance, and the AMID, whatever we supplied using that AMID, it is going to create the resource. It has identified T2 micro as our input and the tag. And all other parameters will be known only after apply. Upon applying the changes, once the apply is successful, then only other parameters will be assigned, like IP address of the machine, public IP, private IP, everything will be known only after apply command. Correct. So as part of this, we can see there is one resource to be created. We'll be creating one resource, and there is nothing to change or destroy. And if you observe one more thing here, as part of the create command, there is a plus symbol associated, right? So that is what the notation here. If you want to create any resource, against the resource name, you can find a plus symbol. Plus symbol denotes we are trying to add some new resource here. Similarly, if you try to make any changes, it will be having a tilt symbol in front of that resource name. Got it? Or if you try to delete the resource or destroy resource, it will be referring as minus symbol. Any question? Any question here?
No.
So as part of our Terraform apply command, it is clear that we are going to create one resource. That is only one EC2 instance is going to get allocated now. If you are clear with this, see it is giving a recommendation. Your Terraform cannot guarantee exact thing, but you can able to proceed with your Terraform apply command. Right? So now you're good to proceed with Terraform apply command. Just run the Terraform apply command now. Terraform apply. Before that, I'll tell you one more thing. Just observe the folder structure. Okay, as of now, this folder is having the Terraform providers and the AWS TF file. If you run this Terraform apply command here, as part of apply command, again it will do a preview and it will create one state file. Okay, let me show you that. See, it is in progress. Just observe this. Okay, terraform.tf state. It is available now. I'll talk about the file in some time. It is asking for the confirmation. Just enter yes, yes to approve. Now it has started to creating the resource. AWS instance 1 is getting created now. Still creating, and it is created. One resource has been added. Now, if you get into your AWS EC2 instance dashboard, you should be able to see one resource, PL test instance 1, which we tagged here, right? That is what tag we are saying, no? This resource has been created. Easy. So this is the quickest way to create AWS resource using Terraform. This is just a simple script. If you want, you can able to add multiple configurations. Say, for example, this AMI belongs to Amazon Linux. If you want to create Ubuntu instance, just have one more resource definition here like this. And as a unique name there, and give its own AMI ID. And if you want to create a T3 medium, just change the parameter T3 medium. If you want to create 10 resources, say count equal to 5 or 10. Save this file, execute your Terraform plan and apply. All these resources will be created in your target environment. Hope you are getting my point. All of you.
Yes.
Fine. So now we have prepared the resource. That is, creation is done. Next, we'll see how to modify the resource. So modifying the resource means whenever you try to change any parameters here, let's say I have a name tag here and I just want to change this tag. Okay, I just want to change this to dummy. Okay, and make the file changes and save the file. Got it? Just save it. So whenever we make any changes in the existing script, save that file. Okay, and you can issue Terraform plan command. No need to give Terraform init because init means it's a one-time activity in your project. Already it is initialized and the provider is available here. Then after, whenever you make any new changes or updates in your script, directly save the file and issue Terraform plan command. That's it. Easy. Am I clear with this or any question? So simply execute the plan. And now you can see it is refreshing the state. That's what I wanted to show you here. When I execute this Terraform plan command, it is saying refreshing the state. State means there is a file called Terraform state file. It is refreshing the state file and it is trying to identify the differences. So in my existing target environment, I already have the tag as PL test instance 1, but currently I want to change it to PL dummy instance 1. So as soon as I execute this Terraform plan command, how Terraform can able to quickly capture the real-time data and the latest changes. From where it is picking up these details? It is from the state file. So state file is used to maintain the current state of your real-time infrastructure. As soon as you execute Terraform apply command, the actual current state of your infrastructure, all these parameters will get updated in state file. If you see the current state of the state file here of the resource, in that resource, you can find the tag. It is assigned as PL test instance 1. But in your latest script, you want to change it to PL dummy instance 1. So Terraform actually it is comparing your latest script with this test state file. Got it? If I change it back, I'm not going to make any changes. Let me save this. And now if I say Terraform's plan, see, it is referring state and what it says now, no changes. Your infrastructure matches the configuration. It means I haven't made any changes here. So it has compared this file with the actual resource. There is no changes available. So it says nothing to update. You see? Can you able to understand the purpose of state file? So Terraform state file, it is used to maintain the current state of your actual infrastructure. Am I clear?
Yeah.
So if you want, I can give you a reference for that state file. Here it is. So Terraform state file, it is actually used to maintain the state of the resources in the target infrastructure. It helps to preserve the target state file. Okay, so it is, I mean, it is required to preserve the target state file. If that state file is not available or if it get corrupted, then you will be losing a track of the resource. Got it? So the state file is mandatory. So now let's make some changes in the script. Let me make it as dummy instance 1 and save this file. And let's execute Terraform plan command again. So it will compare your latest configuration with your state file and it found one new change. Got it? And there is one parameter to be changed. If you're okay with this, execute Terraform, apply command. So when you say Terraform apply, again, it will do a preview of the script and it will give you a summary of that execution that you want to execute. And then it will ask for confirmation whether you want to proceed further. Just say yes. Why yes? That's it. Now one resource has been changed. Just go to your resource definition and you can see, just refresh the page. I mean, you can just refresh the list also. You can see this running state. It is changed to this one. Easy? All clear?
Yes.
Now, the last action item is destroy. If you want to destroy your AWS resource from your Terraform script, so already you have a script with all the resources, right? If you want delete all the resources defined in the script, simply say Terraform destroy. Destroy. See, it is also expecting confirmation from me. If I say yes, it will just identify the resource and delete that resource. It's deleting now. In the meantime, if you verify your list, say no running instance, select all state, and now it is getting terminated. It is shutting down. See, terminated actually. Easy, no? So what are all the three actions you can perform with Terraform? It can be add, change, or destroy. Add, change, or destroy. And Terraform state file is one of the important component in Terraform, which is used to maintain the actual state of the target infrastructure, the real-time infrastructure. So whenever you execute your Terraform apply command or your plant command, the state file will be used to compare your latest configuration with the actual resource. You see? So it is a responsibility of the user to preserve the state file. If the state file is missing or if it gets corrupted, then you cannot access that resource. All right. Any question? Guys, it's all very important concepts, guys. Are you listening or any challenges in understanding? Please let me know. If you're unable to understand, let me know. I can explain it again, but please say something.
It is clear, sir.
Easy to understand?
Yeah, it is clear.
Yeah.
Okay. All right. So if this is clear, then based upon the same process, we can able to define any number of resources in your AWS cloud platform using Terraform. Okay. It's not that big issue. After all, just a script. Okay. So if you want, I'll give you one scenario. Listen, please. So whatever things we did so far, it is just one EC2 instance, correct? But in real-time environment, we'll be doing some end-to-end project actually. So when I talk about the end-to-end project in Terraform, it includes all the major resources, starting from your VPC, subnet, internet gateways, all the resources that helps to isolate your computing environment to perform the test. Let's say, for example, consider I have a testing team and they need a test server to test one of their applications, but they don't want to use the test environment in the common VPC, which is being shared with other users or teams. They need a dedicated VPC, dedicated subnet within the VPC, and they'll be having their own internet gateways, security group, everything. So how we can able to prepare an end-to-end dedicated server in real-time environment? For that, you should first understand the architecture of that environment. So if you can look into this scenario here, in my AWS cloud platform, ultimately my intention is to create EC2 instance. Correct? To create a EC2 instance, if you simply create this script, you'll be getting this script executed by using all the default resources. Like it uses default VPC, default subnet, default security group, everything. But I want to create a dedicated VPC here. I want to create a VPC and then a subnet. I should create a route table. Along with it, I'll be creating a route table association. And then I need to create a network interface. I need a internet gateway as well as security group, and then your EC2 instance, right? So like this, if you want to create the resources which can completely isolate your computing environment, you can able to use your end-to-end project. Got it? Any inputs here?
Like infra team will create this resource, or we as a DevOps engineer need to create it?
No, it is something based upon the infrastructure configuration management team. We never have any access to create all those things. It is just a process. We are going to support them, or your infra team can directly use this Terraform to create those resources. Are you able to relate the things? So first, we have to prepare the architecture diagram. Any infrastructure team will be having the architecture diagram for their resource definition. Once the architecture diagram is ready, then you can directly utilize the Terraform resources. Like for example, if you go to your official page, here we just created something for EC2 instance. Let me show you one more interesting thing here. On the same page, just search for VPC. Okay, so you can able to find something called virtual private cloud, VPC. Under that, you can able to see the VPC resource definitions. You can able to see something called AWS VPC, AWS subnet, security group, route table associations, internet gateways, network interface, right? NAT gateway. So all the resources associated to your private cloud network, you can able to capture it from here. For example, if you click on this AWS VPC resource type, so this is a parameter to create it. To create a VPC, you need the name of VPC that is used by Terraform. We should define the CDI block and then instance tendency. It can be a default or it can be multi-tendency, as well as all the associated resources like creating a subnet, VPC subnet here. Okay, so this is a script to create a AWS subnet. To create a subnet, we use the VPC ID that we just created earlier. Okay. Like this, you can able to see the definition of each and everything. If you are available online, you can just browse through all those things. Okay. Like this is for your security group. Any security group will be having your inbound and outbound rules, right? So that's what egress and egress. We can define it. All right, like endpoint services, a lot of things are there. So as per this architecture, if you want to create the resource, I've just prepared a separate Terraform script for that. So listen, please. Just look into the script here. You can able to create one project and have a provider to ensure that you can able to log into that resource, AWS. And then first we are going to create a VPC. This is a syntax to create a VPC. Resource AWS_VPC. The ID, whatever we're going to give, it will be used by Terraform to maintain in the state file. And then we have a subnet. While creating a subnet, you use that VPC ID, whatever you created, because for this particular VPC only, we're going to add the subnet. And then internet gateway by using VPC ID. And then route table association. And while creating route table association, we have to map your subnet ID and then the security group. Correct. So in security group, we are going to have two things. One is your inbound rule, another thing is outbound rule. So inbound rule is defined under ingress. Outbound means egress. Like we are adding port 8080, port 22, correct? So all these things can be updated here. I just added port 80 and 22 for now. If you want to add port 8080, just copy this block, have 80 as a port number, and center CRE block can be zeros. After using all these parameters, you are going to define your AWS EC2 instance. While creating instance, you are going to use the existing AMI ID, instance type, and we are going to associate the public IP address as true and the subnet. So I'm going to use the subnet which I just defined here. When I refer the subnet, automatically that VPC will be referred by default because the subnet is part of a VPC, right? And then the security group, which I defined with port 88 and the key pair along with the tag. If I say count as 2 means based upon this parameters, it will create 2 EC2 instance. If you don't want to give count, just ignore this parameter. All right. Any question? Okay, just go have a quick break and come back. I'll do one thing. I'll start from the scratch. I'll show you how to create a project from the scratch and add all these things in a separate file. And I'll show you how we can able to, how this can be executed in a real-time environment. Understood? I can understand that you people can be, struggling to understand the terminologies. Like if I talk about VPC, most of you are not sure about what is VPC, what is subnet, what is in a gateway, right? I can understand that from your silence, but point here is this is just to learn about the Terraform. This module, we are trying to understand the capabilities of Terraform. So main agenda here is you should know what is Terraform and how to create a Terraform project and how you can able to write Terraform scripts to create the resource. That's it. But what you're going to exactly create, what is the purpose of VPC, what is the purpose of subnet, that is not the concern for today's module. All these things you'll be learning in detail during your AWS module. That is the reason we have a separate AWS module for you, right? Got it? So don't get panic by looking into all these terminologies. It's not something, it's not a kind of a rocket science here, okay? It's very simple, very, very simple. If you can able to understand the process of Terraform installation and the Terraform working process, like whatever I mentioned here, these 5 steps are mandatory. And you should understand the process of installing Terraform, enabling it, and prepare a new project and write a script and able to achieve these 3 actions. Are you able to manage this? Able to understand this process?
Yes.
Yes.
Yeah, that is the agenda objective of this module. Tomorrow, once we start with our AWS module, there we'll start from the scratch. What is AWS? We'll be starting with IAM service. And then we have something called EC2 instance, database service. Each and every service that is required for your architect level will be learning there. Got it? Just go have a quick break and come back. I'll prepare a project for you now. So let's 5 minutes sufficient or 10 minutes? Is okay, right?
Yeah.
Go ahead, please. Hello guys, so shall we proceed? Or you have any question or any concerns? Guys, all good?
Yes, sir.
So, there is without the Terraform state file.
Terraform?
State file.
It will be part of your project. Within your Terraform project, you can find a terraform.tf state.
So we store that file in a project folder only.
Yeah, project folder. But in real-time environment, there are some best practices. I'll talk about it. Once we complete this, I'll show you what are things you can able to do while implementing it. All right. Guys, any other question? Hope all are clear, right?
Yes, sir.
Okay, fine. So next important item here is how we can able to prepare this project. So it's very simple. If you want, I can start from this scratch. Okay, so let's create a new Visual Studio Code project. Just I open this Visual Studio Code now. Go to your file menu, click on open folder, and you can navigate to the folder location from where you want to create it. So let's say, for example, I want to create this folder here in D drive. I just want to create one folder. So create a new folder, project one, or I can tag it as 2 and use this folder name. So once this is done, once this is done, you can directly create a new file. Just click on plus symbol to add a new file and give a file name aws.tf. Since we already installed our extension, you can see it has opened the default editor. Now you can go to terminal menu, click on new terminal, and you can verify your Terraform access. Because this is available in your default directory. In my softwares folder, I have a Terraform binary, but I'm able to access it through my project folder. It is only because of the environmental variable, the path, whatever defined. Okay. Got it? Now, okay. So now you can able to add these scripts, like the script, whatever I was talking about, right? Starting from your VPC creation, everything you can able to have it there. Simple. So for provider, if I want, I can refer it from my previous project. Here it is. And AMI, I can use the AMI which I used in the previous project. This is the one, right? So I can refer to this one. This AMI ID. That AMI should be associated to that instant, I mean, a region, okay? AMIs are region specific. And the key pair also I'm mentioning here, my latest key pair, whatever I created. If you want, you can create a key pair from by your own, from your VP, I mean, Terraform, through a Terraform itself, you can able to create a key pair. That's possible. And you can have a tag like this, PL dummy server 9, something like this. So here the point is, starting from the provider, it will allow access, and then this statement will create a VPC. There's a VPC ID, and using the VPC ID, it creates a subnet. And based upon subnet, a VPC ID, we are going to define internet gateway, route table association, and then the security group. So based on all these parameters, finally it will allocate a EC2 instance. If you are clear with this script, simply save this file. And what is the first command we should execute here? What is the first command?
Initialize.
Come again?
Plan.
No, it's a completely new project, right? There is no provider in my machine, my project.
Okay, initially.
Terraform
So
init.
we should use Terraform
Need.
in it. This is very much important. Okay, please consider all these steps. Okay, once a script is ready, initialize your Terraform if it is completely new. Got it? So now we can see it is initialized successfully, and it is expecting me to execute Terraform plan command. So now if I say Terraform plan, it will preview the script. And see, as part of this definition, we are going to create some resource plus symbol nodes. We're going to add something, and you can see it is going to create nearly 7 resources, starting from VPC, subnet, internet gateways, right? So it is going to create 7 resources. If I am okay with this, I can say Terraform apply, enter. So this Terraform apply also will preview a script, and if it will give you a summary of execution, what is going to get created, and then if you're okay with it, just say yes. If not, say no. Or apart from yes, you can type any character and press enter. It will allocate. Got it? I'm not interested to create or dump my system with these 7 resources now. That's why I just canceled it. Because I'm 100% sure that if I say yes, it will create all these 7 resources for sure. Right? So this is how we actually work on your resource provisioning using Terraform. Any question? Any questions you have, guys?
No.
Easy? Okay. So that's it, guys. This is how we use Terraform. It's a very common approach. But when we talk about Terraform, the very important thing is you have to be very clear about your state file, because state file is a very essential entity which helps to manage your actual resources. It will always keep your current project in sync with your real-time projects. That means real-time resources. So current project means your current script, whatever you're preparing, that is saved as .tf file. And your real-time script project means it is a real-time infrastructure, whatever you have there. Correct. So as a best practice, we just have our script maintained in your Git repository. Because consider I have a team of 5 members. I have 5 members working in my infrastructure provisioning. All are using the same Terraform scripts or same Terraform infrastructure to provision the resources. So if they are trying to use the same state file, how they can able to maintain the integrity of it, right? Correct? So how to maintain the integrity of it? If only if you maintain that state file in your repository, GitHub repository. And if you maintain it from GitHub repository, you'll be having the various versions of it. You can able to quickly create multiple versions, and you can able to assign it to any user who wants to update. So which helps you to quickly track the changes also. Even by chance, if you miss that state file also, anytime you can able to take it from your GitHub repository. Or by mistake, if you make any major issues or major, resource conflicts, you can quickly revert your changes also. So as a best practice, we just preserve the copy of the state file in a repository and version control it. Understood? Are you understanding how to create a project and maintain your state files? Any questions? All good? So like this, you can able to create n number of resources for your real-time projects. So this is all about your Terraform as per your curriculum. But apart from that, we have a lot of things on advanced level also. And tomorrow, once we start with the AWS module, you'll be learning about CloudFormation template as well. CloudFormation is another IAC tool that is meant for AWS service provisioning. So there again, you'll be getting the comparison between CloudFormation and Terraform, and you can able to relate the things on resource provisioning as well. Correct. So tomorrow, when you create your resources through CloudFormation, try to create the same resource using Terraform so that you'll be getting hands-on both the tools at the same time. You see. Now, apart from your content, course content or something, I would like to share something on your real-time project perspective. Projects, like for example, on DevOps perspective, how to use a Terraform. Can you able to figure out? Can you able to guess something? On DevOps perspective, how you can use Terraform? Let's make it as a discussion, okay?
We can manage the resources in the infrastructure level.
Sorry.
Yes, we can manage the resources in the infrastructure level, means instances and all the plugins.
Okay.
Yeah.
So we
Mm,
can create the script for launching multiple instances, EC2 instances.
okay. Any other thoughts?
So we can integrate Terraform with Jenkins.
Okay. Okay. So when we talk about DevOps perspective, right, we always think on the process of automation. How I can able to automate the provisioning. Using Terraform, I can create it, but dynamically, how I can able to create? If I want to do it dynamically, I need to enforce some process automation. That is where the DevOps comes into picture, right? You can create huge resources, everything is fine, but how you are going to automate it? In which situation will be automating it? So that is a very important thing to be considered while implementing your uh, things on real-time environment. So I'll give you one good example, okay, which we use with some of our customers. Okay, so if you can consider a scenario, okay, it is just for your reference or for your knowledge. Tomorrow during interview, they might ask you like how you can use Terraform in your DevOps process. Means you can talk about all those things. Whether you work on it or implement it, that is secondary. At least you should aware of the process and relate it to the real-time scenarios. So there is one real-time scenario. Consider I have an infrastructure management team. They want to create the infrastructure. It means as part of my CI/CD pipeline, remember in your Jenkins module, what you did actually? What are stages of a CI/CD pipeline?
SCM checkout.
So you had SCM checkout and then application build you did, right? Yes or no?
Yeah.
Yes.
Application deploy.
And then you deployed. to target server. That is your test server. Can I consider a test server like QA server?
Yeah.
So before you trigger this pipeline, your build environment and your test environment should be available, should be up and running, correct? You must have configured a build server, then only you can perform application build. Similarly, deployment target server should be configured and up and running. Then only you can able to execute your deployment. But most of the case, what happens, this application build server already you have in your Jenkins environment. That is a static server. But the deployment server, target server will be the dynamic server. At runtime, we need to create it. So what I can do here is I can have one pipeline. Okay. Already I have a pipeline for my CSD application builds and deployment. I don't want to disturb this pipeline. So I can create a separate pipeline. And this pipeline can perform SCM checkout. And once SCM checkout is completed, I can provision the resource. Provision a new test server. Once test server is created, you can configure new test server. So how to provision the test server? Which tool you can use here? Which tool we can use to provision the test server?
Terraform.
Terraform. And for configuration?
Ansible.
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 Okay. So what I'm going to have, why I need to check out this? What will be there in the source code repository then? The repository will be having my Ansible playbook. That is my entire role, Ansible role directory, which includes my playbook scripts, your task definitions, everything, and your Terraform scripts. So for infrastructure management team, this pipeline is meant for your infrastructure management team, which maintains the ISC source code. Okay. As like an application development team, infra team also will be having their own source code repository for administration activities. They can maintain all the scripts in that source code repository. And using Jenkins, we can able to automate this process of resource provisioning and configuration. Once this pipeline is completed, then you can able to create one more pipeline, or you can use the existing pipeline. Pipeline 2. Hope my voice is loud and clear to all, right? Or any disturbances?
It is clear.
Clear.
Application build, and then we can have deployment. Deploy to the new test server. See? Clear? So I'm not going to change the existing pipeline. Existing pipeline will be there as it is. I just create a new pipeline and provision the resource. This pipeline is meant only for resource provisioning. Correct? This is scenario 1. Apart from that, there'll be another scenario. You guys heard about GitOps? GitOps, any idea? So as part of GitOps, right, your application source code as well as your configuration server ISC code, everything will be on the same repository. So they'll be having one pipeline. This pipeline will perform the SCM checkout. Okay. Once SCM checkout is completed, they'll perform the application build. Once application build is completed, they'll perform the resource provisioning. And once resource provisioning also completed, they will configure the resource. And upon configuration, all that they do here is they will deploy. Can understand the process flow now. This one, deploy to new server. And once deployment to new server is completed, they will perform the automated testing. Once the test automation is completed, what next? What next? Once testing is over, what we usually do? Guys, are you getting this workflow? I'll be doing SCM checkout, perform application build, everything. So if I can able to perform the application build and resource provisioning means my source code should contain the Terraform script, Ansible playbook, as well as the application code. Correct? This is what the expectation. So a simple source code repository will be having all these components. So developers, as soon as they commit the changes in source code repository, based upon the Ansible playbook and Terraform script template, it will automatically provision resource, configure the resource here. And then it deploys that application into the new test server, perform the automated testing. And once automated testing is completed, the users will be notified about the status through email, about status of testing. If the testing is successful, we can able to deploy to the next environment. If the testing is not successful, what will happen? I just notify the status to my development team. Now, this development team has to work on that particular changes or fix. And again, they will trigger this pipeline, correct? Yes, no?
Yes.
The pipeline failed because of the application testing, not because of any other resource issues. So there is some failure in the test case. So development team has fixed the issue and they will try to trigger the pipeline again. When they trigger the pipeline, what will happen now? Again, it will perform SCM checkout. It will pick up the latest changes and it will perform application build and create the artifacts. What about this stage? Whether it will create a new resource here or not?
No.
No.
Already the resource is created, right? So it won't create any resource. Why? Because your repository is maintaining the state file. During the provisioning of resource, it will compare the resource definition. If the resource already present, it won't create it. If this stage is not executed, you can able to write a logic to bypass the stage, and then we can deploy it to the target server. So this is one scenario. So it means whenever the developer comes with the new changes, they can able to use that server which is already created. It is not going to allocate any new resource. This is one approach. Some teams might be using this scenario. Sometimes what happens, consider another scenario. This is also another real-time project you can consider. Consider there is another scenario. Here also we are going to follow the same process. But here there is one issue. In our previous case, we have notified the development team about the testing issue. Development team has to immediately fix that issue and trigger the build. What if the development team is not fixing the issue immediately? Let's say they are taking a day time or a 1 week time. What will happen then? Because we cannot expect, right? Development team will immediately give a fix. We can't expect. There might be some critical issues also. They might need time to fix that issue. It may take 1 day or 2 days or even a week also. All right. So till they come back, the resource whatever we provision will be up and running, correct? The test servers. Do you really want the test server to be up and running?
No.
No, sir.
Not required. No. So in scenario 3, what I can do means I don't want to use my resource. As soon as the testing is completed, automated testing is completed, I just delete the resource. Destroy the new test server and notify the user. That's it. That's it. So now what happens? Whether the testing is successful or not successful, that is secondary. My testing is completed. I got the test report. Once that is done, I can simply delete the test server. That is no longer required for me. If testing fails and if developer wants to do the testing again, let them trigger the pipeline again and it will create a new resource. What's wrong there, right? So dynamically, we can able to create the resources any number of times. If it is not required, you can immediately delete the resource. This is the best practice. Right. So please keep all this thing in mind. Okay. Tomorrow during interview, you can talk about all these scenarios, even in real-time environment also. If you need to discuss with the customer, you can add all these points with them. Make sense? You can understand, right? The process of managing resources dynamically. Yes or no? So we have something called AWS pipeline, Azure pipelines and all. So there I'll show you, you'll be learning how you can able to automate those resource provisioning and dynamically creating the resource and dynamic deleting resource through the pipeline. You can see the demo there. Any questions from anyone? Guys, please respond. Are you comfortable with this?
Yes, sir.
So if you follow my class notes, yes, definitely you can able to understand and implement by yourself. This is a repository, right? Okay. Yesterday I prepared a class notes for Terraform. So I'll do one thing. I will update all these notes today for today's session. What are things you have learned? I'm updating it here. And I will give you some more commands in a separate file. Oh, sorry. I made a big mistake now. Sorry. There's a script, right? Let me remove this keys, okay? I don't want to share this key with you people. Because out of curiosity, if you use my key, then better I will remove it. And don't use my keys, okay, ask a secret key. Just try to create by yourself and do it. Otherwise, you know what will be impact, right? So the scripts, whatever we prepared here in this project, I'll be sharing the scripts with you along with the commands. I think this should be fine, right?
So look, Sai, when we are creating the instance in this Terraform, so where we can see in the AWS means we have created one instance in this AWS.
Yeah, go to your instance list.
Okay.
Here you see,
Okay.
right?
Okay. Okay.
I showed you, no, like, have you observed? Now it is terminated. Earlier, you can see that, right? That's what. So what you can do, you can first create a simple script. I mean, just a EC2 instance without any VPC and other stuff. Try to practice all the options like create, update, and delete actions. And then you can use your VPC definitions, everything. Okay. So the commands that are required to execute this, I'll be sharing that as well. Okay. So you can use Terraform init, Terraform plan, Terraform apply, as well as Terraform destroy. And also initially you'll be giving Terraform version command to check the version. Just practice with all these things. Once you're comfortable, then you can explore it. And there are some options also for Terraform add, apply or destroy, like auto approve. Like if you noticed, when I execute a Terraform apply command, it is asking for confirmation, right? Whether you want to proceed further or not. Have you noticed?
Yes.
Yeah.
When I type yes, then only it goes, correct? Same thing, if I want to do it through my pipeline, consider I have a pipeline here. In this pipeline, I'm trying to provision the resource. So when I issue the Terraform apply command as part of this stage, and if it is expecting my approval, then how it can be an automated process, right? So when you implement it through your pipeline script, you should not do it the things manually. Okay, there should not be any manual intervention. Further, what you can do means you can have an option along with the apply command. You can use -auto approve tag. Similarly, while destroying resource, if you say -auto approve, it won't ask for the confirmation at runtime. It is a process of approving it, and it will take it further. Without any manual intervention, if you want to implement this, you can add this tag along with the apply. Otherwise, you can simply run this. Getting a point? So just practice it. Make yourself comfortable with this. Tomorrow, once you start with your AWS and Azure, again, you'll be revisiting this module, and you'll be learning how to create Azure resources using Terraform, as well as Azure Resource Manager. Similarly, Google resource using Terraform. So Terraform is very much essential to provision all such resources. So you'll be always reading all those things with the respective modules in the future. To learn all those things, this is just a like an introductory module for you to understand the fundamentals of Terraform here. Easy. Hope it's clear to all.
Yeah.
All right. So the documents are up to date. Please ensure that you practice this. Tomorrow it's half, right? Tomorrow you won't be available, right, for this session. You must be having your mentoring session, I believe, right? You have or not? It's cancelled. What happened?
We have it, I guess.
It's Wednesday, right? To schedule, no?
Yeah.
If not, tell me, we can have it. Otherwise, you can attend it. And on Thursday, we'll be learning about your Prometheus and Grafana. The next item in the list is Prometheus and Grafana. And then we'll be talking about your project. So Thursday and Friday, we'll be completing these two items. All right. Any question? All right, guys. Thank you. If you don't have any other question, you can log off. We'll connect on Thursday. Thank you all.